From Paris to Berlin, discovering fashion style influences around the world. Fashion is an evolving phenomenon, where clothing style trends go through cycles of evolutions and follow certain migration and influence patterns across the world. Learning about these influence patterns provide us with a unique view of fashion, and may provide us with answers to interesting questions like, to what extent did the runway styles in Paris last year affect what US consumers wore this year? And how long does it take for a certain trends favored in New York City to migrate to Austin? We propose in this work a novel model that learns style trend from images and grounds fashion influence with forecasting accuracy, where we notice that an influencer provides us with unique cues that foreshadow changes in the influence city and help us to accurately predict the style trend in that location. We start by learning a set of fashion styles from everyday images. These styles are modeled as a mixture of visual attributes that describe the color, shape, and pattern of clothing. Then we leverage the meta-information associated with the images about its geolocation and timestamp to measure the popularity of a style in each city. We identify two main properties of the influencer: time precedence, where the influencer demonstrates changes in its trend that happen before the observed impact of the influenced city; novelty, that is, the influencer has novel past information not observed in the history of the influenced city. We capture these influence relations using the Granger causality test, which tells us whether one style trend has a significant impact on another in terms of reducing its forecasting error. Our neural network model takes these influence relations, shown in orange, to better predict the future of a style in each city. These relations are determined, as explained earlier, using a statistical test over the forecasting accuracy. We also propose a novel coherence loss. This loss ties the forecasts from the different cities to be close to the overall changes across the world for that style. We found that this loss makes the forecast more stable and robust to noise. We evaluate our model on a massive dataset of Instagram images collected from major cities around the world. We found that our influence-based approach leads to state-of-the-art forecasting accuracy of style popularity. Our model outperforms previous methods that consider style trends in isolation or follow a holistic view without regard of influence. Our model discovers interesting influence relations among major cities around the world. Here we see the influence pattern discovered among European cities. Our model identifies how each city exerts and receives fashion influence in relation to others. We discover various types of influence patterns, like the fashion hub that influence multiple cities or the influence receiver. We can also measure the influence of a city on the global trend of a style. We find out that some of the styles are mainly influenced by one or two major players, while others show a diffused influence pattern among multiple cities. Finally, our model provides us with a world view of fashion influence, where we can rank cities based on their aggregated influence score. We also conduct a study on the correlation of the influence relations discovered by our model and city properties like GDP and population size. Additionally, we analyze the dynamics of the city influence and how it changes through time. For more on this and additional interesting results, please see our paper.